Chapter 19. The First Principle. Applying the Laws of Physics to the Economy and Our Tax Structures. Part 1.
Amazing as it sounds, there is an emerging field of study where scientists are applying the laws of physics to economics. Imagine the constructs of science and math being used to analyze the economy, and how we might unearth a far greater understanding and predictability of our shared economic world. Imagine analyzing the efficiency of a tax system's structure using the laws of physics and with mathematical rigor. Imagine if we could scientifically test the efficiency of progressive taxes against the efficiency of the ABT tax and see which is more mathematically effective. This has started to happen. In everyday life, we often do not notice the principles of mathematics and the laws of physics at work in our inanimate world, biological systems, and human society, but they are there. Scientists have long recognized the foundational importance of symmetries in the laws of nature, which is also bedrock to the development of mathematics. The Nobel laureate Eugene Wigner extended this concept, observing that the symmetries of the laws of physics in fact determine the properties of particles found in nature. That is to say that the mathematical principles of symmetry has showed up in plants and animals. Radial or rotational symmetry, as is mirrored in physics and mathematics, can be seen in the interactions between molecules, the patterns of leaves, and the fur and color of animals. By extension, consider the symmetry we see presently in society, in human designs like cathedrals, palaces such as the Alhambra, or in the layout of the White House. Following symmetry, the architect and futurist Buckminster Fuller designed a structure called the geodesic dome, which is directly modeled upon the makeup of a carbon atom. Humans have further extended the math and science of symmetry into our art, another area where mankind inserts the math and science of nature into the human realm. This is seen in another scientifically mathematical construct called the golden ratio, which manifests across much of human society and art. In going back to classical Greece and Euclid, this concept is also called the golden mean or divine proportion. It is a fascinating principle. When the length of one line is added to the length of a second line, if the sum has a ratio that is the same as the ratio of the larger line to the smaller line, then this line contains the golden ratio that is 1 to 1.618. In nature, consider the spiral of a flower petal, a nautilus seashell, a hurricane, or the spiral of the Milky Way galaxy. All are perfect manifestations of the golden ratio. The human body, our heads and faces, also all contain the golden ratio. And in turn, the golden ratio has shown up in art from Leonardo da Vinci to Salvador Dali. In seeing how the laws of science resonate across all of society, for the past 30 years, scholars have begun to analyze the close relationship between physics and economics. There is even a name for this new field, econophysics, or as it is sometimes defined, thermodynamic economics. Interestingly, consider this. Economics has only been around for little over 200 years, and is a social science field of study based upon observations, data, experience, traditions, and politics. By comparison, the sciences of natural philosophy and mathematics started over 2,300 years ago with the classical Greeks, and modern science, as we know them today, began to develop in earnest during the 17th century when the methodologies of science and mathematics as a form of language to describe nature were soundly established by Galileo and Newton. Since the 1600s, one of the hallmarks of modern science has been the logical and mathematical development of scientific structures using the scientific method and its foundational question. What is the verifiable first principle to the theory or concept? In science, if the first principle, the logically foundational structure derived from verifiable evidence, is not correct, then the theory or system is flawed. As Alexander Hamilton said in the Federalist Papers,
There are certain primary truths or first principles upon which all subsequent reasoning must depend.
so as we think about our tax structure and our 70,000 pages of tax laws and policy, ask yourself, what is our tax system's first principle? It is nearly impossible to determine, right? Instead of asking our tax system to efficiently achieve a goal, such as gathering revenue in the fairest and most effective fashion, we have allowed it to morph into a black hole of differentiated statutes, policy prescriptions, industrial favoritism, unequal tax credits, special interest loopholes, and more. In short, we have turned the tax system into a mirror of our messy political system, complete with its myriad partisan conflicts and priorities. But it doesn't have to be this way. The current paradigm can and should be disrupted. The tax system should be based on economic, mathematical, and scientific structures. And the first principle could and should be something like establish the fairest and most effective system of collecting revenue from the people to pay for common resources provided to citizens and communities by the government.